Okay, so we're going to look at the general form for an exponential function again. So f of x equals a e to the x. And we know some things. We know something happens if a is positive or negative, and a can't be 0. So, and b has to be greater than 0, and it can't be 1. And it makes a difference if it's between 0 and 1 or if it's greater than 1, whether it will be an exponential, growth, or decay. But it'll still be an exponential function. And remember, the domain for x was all real numbers. Okay, now I want to go back to why b can't be negative. So let's say you had something like some function, and you had like -2 to the x power. Well, what happens if you put in, 2, or let's put in 3 for x? Then you have -2 cubed, which is -8, right? That's fine. But what if you put in like 1/2 for x? Because remember we said x is all real numbers, the domain is all real numbers. Then you get -2 to the 1/2, which means the square root of -2, and this is not real. So then we run into a problem, okay? So that's why we're saying that the base, b, has to be greater than 0, okay? All right, so I just wanted to go over that kind of quickly. All right, so in this example, they want us to see which ones are not exponential functions. It says, which of the following equations are not exponential functions? And they might be a little tricky here. So notice on this first one, f of x equals 4, that's the base, okay? That's what we're raising to an exponent. The exponent is 3 times x minus 2. All of that is the exponent. And sometimes it's hard to tell with the typing, so you have to be really careful where things are. Okay, is this okay? Is this an exponential function? This is okay. This is exponential. Exponential function. I'll just put exponential function. Okay. Now, back to that. B has to be a number, right? A real number, greater than 0. Okay. Let's go to the next one. Is this an exponential function? Now, if you want to stop the video and see which ones you think are exponential functions and which ones you think aren't, that'd be a good idea. And then you can watch and see if you're right. But if you're not feeling comfortable with that, I'll just go through these. Okay. Is this an exponential function? No. No. The base isn't a number, okay? So the base is not a number greater than 0, okay? It's x. That's where the variable is. In fact, what is this? This is a polynomial function. This is a polyfunction. Polyfun. Okay. So that one is not an exponential function. All right, let's go to the next one. Is this an exponential function? Well, at least I have the exponent being the variable, so that's good. What about this base? Can I have the base be 1/3? So b in this case is 1/3. Is that okay? And yeah, that's okay. It's between 0 and 1. So this is going to be an example of a decay as opposed to a growth. But that's okay. It's still an exponential function. So yes, this one's okay. This is an exponential function. All right. And then what about this last one? Well, it looks pretty good. You've got the exponent there, the variable in the exponent, so that's good. But what about the base? In this case, the base is -2, and can we have that? No. The base is not greater than 0. B is not greater than 0. So this is not an exponential function. This is something else. Okay, so not exponential. So you probably want to know about that j of x a little bit more. You could have something like that if you had some specific restrictions and things, but it's going to do something very odd. It's going to toggle because as your exponents go from positive and negative, it's going to change the output. And so it's not going to fit into what we're going to do in this class, particularly this semester. So it's not that it couldn't occur someplace at some time, but we're not going to see that.